All right, guys. So today is another Saturday. It means nothing but AtCoder. So let's go. I guess. Which one of this is the entire screen? All right. All right. So as usual, AtCoder beginner contest 195, sponsored by Panasonic. Should be interesting, I guess. I think Panasonic sponsors like a lot of contests. First, I remember something like 186 was their contest as well. So, um, interesting stuff we're going to see today. We will see the problems in a second now. All right. Open the submit type menu. Open tasks for printing. All right, good. Takahashi the magician is fighting with a monster. His magic can defeat a monster whose health is a multiple of M. It has no effect on a monster whose health is not a multiple of M. And his magic defeat a monster whose health is H. Okay, so apparently we just want to read MH. If M, wait, if H modulo M, then we want to print no, otherwise we want to print yes, because like when you take this, you effectively get like whether it's non-zero or zero. Right, so 120 yes, 0 yes, okay. Should be good to go. I mean, obviously we can test on examples, but yeah, there's no need to. Problem B, many oranges. We have many oranges. Good for you. I would also like to have many oranges. So it is known that every orange weighs between A and B grams in clove can have non-neutral weight. All right. We choose some of those oranges, and their total weight was exactly K kilograms. Okay. Find the minimum and maximum possible number of oranges chosen. All right. What is the input format? ABW. All right. Let me see what's the minimum. I suppose there are like several oranges. Let's say we have X oranges. Then we know the following conditions should hold, right? So let me distribute it into two conditions, because like X is going to be one side, like smallest, maybe largest, and Y is going to be the other side. So here, what do we get? We get X is at most V over A, W over A, right? And here we get that Y is at X is at least V over W over B, right? So one thing we want to print is V over B, minimum maximum, right? Oh, there's no number of formulas that can have the specified total weight. Right. So lower is V over B, upper bound is V over A. But like here, we want to round down. This is exactly what integer division does. But here, we in fact want to round up. And for this purpose, we're going to use this trick. All right, now we have like, the only way for it to be wrong, I see it's like when W is actually smaller than A. Oh no, that's not the only way, right? And it's like between 2 and 3. Yeah. Yeah, let's say this interval may be very small. Like say every orange is between 9 and 10 grams. and it's kind of tricky to get 15, right? So in this case, estimates for 15 will be like a lower bound will be 2 and upper bound will be 1, I guess, which is unsatisfiable. Right? A bit longer than we should be working on this thing. But yeah, it feels like a problem where you should be accurate, you know, because otherwise bad thing gonna happen. Just almost typed it correct the first time. That's not good, because the first one is satisfiable. Oh, because we is kilograms. Right, I have to recompile. Answer is 1020. The second answer is 1416. And last one is unsatisfying. Sample G's. I think we were accurate enough. We have two obvious upper bounds and lower bounds. Yeah, all right, accepted. Let's go to problem C. Problem C, comma, when Takahashi writes an integer, he uses comma every third digit from the right. For example, okay. When commas will be used when he writes in each integer from 1 to n once. And n is kind of big, okay. But not really that big, right? Because if you think about this like this way, in integers from 1 to 1 side, let me say commas equal to 0, and the end will bring the number of commas. Let's say so. Actually, well, it's kind of weird. Let me think, like, you know, the first thousands of integers from 1 through 999 has no commas. So from 0 all the way up to, yeah, I'm gonna write it like this, okay? So from 1 to 1000, there are no commas. I'm actually going to write it like this. Hold on. All right. So here we have 1 comma. I have 2 commas actually. Here we have 3 commas, 4 commas, and well, n can be equal to 10 to the 15, so we are going to say it's 5 commas. So now the thing about this is that like when L gets bigger than n, it doesn't make sense to continue, right? That's the first thing. All right, and both L and R get multiplied by 1000, and it should be good. I mean, like R can be actually get too big, right? If we were to continue multiplying, so that's why we have 10 to the 15 and not 10 to the 18s. So number of commas should increase by, and we need number of commas. I'm not being smart with names, I'm just writing something more. The number of commas per number, right? And then multiplied by the total number of commas in this range. So in the range is from L, right? From L to R, not inclusive, but maybe N is smaller than R, and we want to take a minimum of R and N should be inclusive. If we take like this, it should be fine, I think. And also the total number of commas can get like 5 times number of numbers. So that's interesting. Let's see if we compute this correctly. I may as well just is it the correct number? 10,77302 7213. So 3 4. Yeah, it sounds legit. I mean, why don't we just try it? Ever since it's long, that should be long, is long. So yeah, we are fine. Good. Next one, please. From the shipping center, we have n pieces of baggage called baggage 1 through m, and m boxes called box 1 through m. Baggage I has the size of wi and value of vi. Box I can contain a piece of baggage whose size is at most I. It cannot contain 2 or more pieces of baggage. Okay. We're given Q queries, and each query we're given to integers L and R to solve the following problem. Out of m boxes, R minus L plus 1 boxes, box L through R, have become unavailable. Find the maximum possible total weight value of a set of baggage that we can put into the remaining boxes simultaneously. Constraints are kind of low. So I guess we can solve the problem independently. No, I don't know. Like, how should I solve the problem if it was independent, like only one query? So I have remaining boxes and several baggages, pieces of baggage, right? Maybe there's no such word probably. We cannot have too much weight. We want to put maximum value. I don't even know how to solve a similar problem. You want to solve me 50 queries. That's unclear. I'm not really good at combinatorial optimization, so I guess we'll have to think for this one, about this one for a little bit longer. I mean, we can always read the input, right? Whatever. Oh, I don't want that. Let's see. Yes. And we would need to write this for loop either way, so that's okay. I mean, really, like you type this explicitly, but then you say like query Q. Whatever. And shall I do something here? Obviously, we cannot try all permutations. So we should be smart on this. No, digits in a string again. Yeah, I guess we better solve this one first. So we do have pieces of baggage. Right, but it's not clear. Not clear. When this problem has no nice features, like you can solve on one segment, then on the other segment combine the results somehow, I don't think it has. How do you actually do this for one query? I still don't understand. Do you have to employ some sort of greedy algorithm? Like sort boss them on weight? No, sort, what do you sort on even? What the heck? I mean, obviously, each item, each piece of baggage we're going to take, it is going to go to the box with the smallest size that it can go to. But then if we do it in different order, it's not clear. How are we going to proceed? Yeah, suppose we sorted boxes on sizes they can contain and pieces of baggage also on size. And if when we have like, if you just have a set, yeah, we sorted baggage on size, but then we added to the sets based on value. Now we encounter that's going to be 50 times 50 times log 50. I guess we're fine. Yeah, we're just fine. So what we're gonna do? No, I'm not. Again, I guess. That's fine. That's fine. Okay, I understood my mistakes, please. Please let me write it nicely now. Might as well just tidy up this a bit. So now I want to sort WB based on what? I actually don't know. Based on the first component, I guess. Well, I can just sort it like this, right? Right. It's going to be the remaining guys. Algebra all inclusive, okay. Start here, go up to here. The idea is that we're going to do the following. I'm gonna need a helper function because there's no way I'm doing this. Just too many variables can have collisions and stuff. Here. No, I'm gonna copy by value because I'm gonna not trivial process. So what we do is we know that W is sorted on W and XX is sorted on X, right? So we're going to create two indices actually. We're gonna need some sort of answer as well. It is the following, like if you scan bus from left to right, from smallest weight to largest weight, you can just employ greedy. Doesn't make sense to look for now. We have at most 50 times 10 to the 6th, we can do it without overflows. Again, that's a supplementary data structure. Then we have several conditions. If I first is smaller, than xxj, values can be the same, right? So we need to set but we want to insert the value, right? Or actually, because this value it makes sense to like this. Second, of course, plus like else. That's actually here. Else, like we can't add more. Oh, I'm gonna need this condition. Else, yeah, but this actually checks for boss value. That's virtual logic, but so here, what we know is that oh, that's just I don't know. It's annoying. I don't understand how to iterate it correctly. Like else, like the smallest remaining is a back box, right? Box. Uh, this box allows to take the highest value from multi-set. Can we actually do it like this, or do we need? Yeah, I guess we need this because we're going to erase iterator and multi-set. I don't think it can erase reverse iterators. Multi-set. And also we got to implement the box ID. Whenever we run to the end of boxes, it means the end of processing. And whenever we add, no, when we run, like if this condition is no longer true, and we get a step, we still have to continue processing this space. We got to check that it's not accurate. That's pretty terrible codes. I don't really know. That's why I don't really like combinatorial optimization. Well, that's kind of makes sense because we do regularly. we're given multiple like queries per test, but it's strange. Yeah, for example, in second query we apparently returned 9, although we should not have returned 9. How is that? Oh, right, because I did not do commands as usual. Let's see. Like everything should be fine legitimately, I think. Like we just do it in greedy for each query, and there are not that many queries. Greedies itself don't take much time. Yeah, we should not fail. We should face no problems on this one. Just see how it goes. For a quick second, I'm gonna pause the camera because I clearly need to fix the light. Oh, that's terrible, actually. Yeah, now we got to fix this somehow. I'm not really sure how. And we have a lot of wrong answers. Interesting. Very, very interesting. And not really good. But we do have a lot of correct answers. And keep in mind, these correct answers, they have like multiple test cases. So we may be like wrong in one of the test cases, not the entire. Well, I mean, in one of the queries, not one of the test cases, like perfectly. So let's think. This is sorted. This is also sorted. We do not push L. Do not push R. I think we are fine with indices. Maybe run somewhere here. Should not have problems with overflow, but it costs nothing to change it, right? Well, it actually costs quite a lot for multi-set to have int64 instead of int, like 4 times, I think. Slower, but with our execution time, definitely have to think not about execution time. While I have boxes left to process. Oh, I'm stupid. If we is empty, we just do nothing. We don't break. Damn it. This case is actually not going to show us a problem, right? So we get to write our own test case. I guess we can do it like this, that manner. So this should give us wrong answer, just to make sure. Baggage. Now, let's say it actually has like quite a lot of weight. Actually, one piece of baggage. No, because we got to ban something. So let's say it has. They are identical. Both weight 3 kilos have one value. Not very well, but it's okay. Now the box is that we have. Let's say. Yeah, actually, we could make it this one. Now we have like 2 boxes, both of size 2, and the query we're going to ban from 1 to 1. Like I think that now we get the answer of 0 because we break. Oh, let's see the answer because Yes, okay. What if I erase it? No, no, no. Okay, this part. Like this. It should be like this, right? So it does not break the first test case, but oh, because okay, yeah, we're gonna need 3 bags, I believe. One of them, we'll have like one of them can fit it, the other one can't, and we ban the second one and the first one. Whatever. So in this version, answer is still 0. What is it in this version? Here's the answer is 1. All right. So we found a bug, which was that we don't have to break if we is empty. We just don't get anything into this box, this particular box. That's unfortunate. I understand that you are not satisfied with me because I should not make such mistakes, but sometimes they happen. Okay. Yeah, we got our accepted. Let's go to E. Like I said in battle, I hate digit problems. I think they have no like value whatsoever. I really want value. I doubt that any like. Well, it's relevant, all right? It's relevant. We have a string S of length and consisting of 0 and 9, and string X of length and consisting of 8 and T. Only and 8, okay. Additionally, there is string T, which is initialized to an empty string. The Hashim hierarchy will play a game using this. The game consists of n rounds. In the first round, the following happens. If x, y, I is a, hierarchy does the operation below. If okay. So A and T determine who's gonna move. Operation append as I or 0 at the end of T. Also, they have a choice. They have to append like either the card symbol of S or 0. Train operation T will be a string of length and consisting of 0, right? So if T is a multiple of 7 is a base 10 number, that's irrelevant. The hashings always in our case. Okay, we want to determine who has one strategy appropriately. Let me think, what is the divisibility by 7 pattern? I guess we take blocks of size 3 and take them plus, minus, alternative sign. If the sum is divisible by 3, then we get. Otherwise, we are not very good. Is it relevant? Problem. I think there's no hacky message. We just get into our sync, which is, of course, DP. Or is it not a DP? No, it should be DP, like win and losing positions, right? Right? Am I right? I don't care what is the current remainder model of 7. So let's actually read the input, I guess. Who's n? N is integer. S and x. Two-dimensional, because we want to know the remainder model of 7. Let's say n plus 1. I don't know if we're gonna use it actually, but let's say so. Let's rationalize it to like it's fine, which means that I don't know who's gonna win. And let's say nicer to have it as a string of who wins and who doesn't win. No, I would just mess it up. Yes, we're gonna do it like this. Make the one is unknown, 0 is okay, your wins, 1 is Takahashi wins. 0, like first is the remainder, second is how many moves there are. Remaining. Oh, actually, -1 is. Wait a sec. Okay, let's say like here, clearly Takahashi wins, right? Here, I'll give this. But am I even doing the right thing? This game is quite confusing. I'm not sure that I'm doing the right thing. We're gonna do it anyway because I just don't have better ideas. Sometimes it just happens. So we'll need power of 10, modulo 7. We'll need 5, which is which will have to be this way. Please don't shout at me, but using one based indices, I have no choice, okay? This is how it goes when you have n+1 in BP. All right. Power gets multiplied by 10, modded out by 7 should be fine. I get synchronized. Okay. What was the string? Yes. Strings, in fact. Effects. No, okay. Okay, good. That's always a very good idea. So if you are shooting at me, then you are absolutely right. Shouting? Right. Yeah, I think it's shouting because shooting is not really that good. Right. We have a optimist and we have the question. I love X determines the choice. Okay. Yeah, I'm going to write this. Let's hierarchy store. He's got to check, you know what? If dp at remainder. Oh, it's not clear. Okay, you know what? Remainder gets what? Gets remainder plus the power of 10 times si converted to integer. How does it sound? So we can use old remainder. We can use new remainder. That's no, that's actually not clear. The current position is winning for the rookie. If he can move to any position that's winning for him, is I one smaller. MDP remainder I is equal to 0. It's also equal to 0, right? If he moves the game into this situation, then he wins and he is good. Otherwise, it's Takahashi moves. Takahashi's move. If he get into this position, that's good. Then he wins, right? At least one of his turns. Goes there, then he can win. But who wins if it's like, oh, these states are like unreachable. Unreachable is actually. Pretty confusing, actually. Wait. Can move to at least one position, or he wins, Otherwise, it's actually important. Otherwise, he loses, right? Because he can't be moved to the position where he wins. Equal to -1. I believe we should end up with something like this. Is 1 instead, right? Yep. Here. Well, game is not that bad with digits, so really close. That's equals. If this is 1, then just copy it because can't write names properly. Not sure if this is actually doing the thing that I intended it to do. Let's see if it's close. Well, that sounds reasonable. And it's kind of complicated stuff is enrichable. I believe you can do it much easier. That's well, I mean, what's the chances? Like if we write completely random, something completely random, then it has a chance of 1/16 to pass 4 sample tests. So we don't have much of a guarantee that we are correct. But I also don't have much of a desire to check everything carefully. So we'll check if we need to check. No, we don't need to check. That's no idea. Like the idea is just you compute a win and losing position, and that's it. Problem F, coprime present. We have b minus a plus 1 cards. For each integer from a through b, we have one card with that integer on it, inclusive because plus 1. You will give some of them possible none to your pets, whatever. Snook will be happy if for every pair of different cards, the number written on them are pairwise coprime, otherwise he'll be sad. I'm not going to question how the pet knows what pairs of numbers are coprime, what are not, but yeah. When a set of cards will make Snook happy, that's insane. Okay. Well, at least it's fine, right? The statements are fine. Obviously not that, don't want that, we want that. Difference between them is quite small, but clearly not small enough for anything like take all submasks. Yeah, it's clearly not enough. Let me actually just quickly, I actually have this one headphone, which is not playing any music because I forgot to turn the music, so I'm gonna just play something for myself. It's not gonna be distracting, but I guess this is a problem when you check your notebook, your paper, I guess, and you start thinking like properly. Like the first idea that comes to mind is that like what can ruin our day? What can make Snook sad? Well, if we have like one prime number that divides both of them, right? And because b minus a is not 72, we don't have that many primes that we can make Snook sad, right? If they have a common divisor, then they also have a common prime divisor. And you can just think about this in these terms, right? So we clearly need all primes up to Thank you, Google. Then I'm gonna call it BS in the honor of Play Snook. Really good game console. If you don't know it, check out the last week's video. Or maybe 2 weeks, I'm not sure. So we have some prime numbers. These are the guys who can ruin our day. I just want to avoid any trouble with that. What I say that we have like edges that prohibit something. No, it's not good. Yeah, we should not think about our problem as a graph, or should we? No, we're gonna face the max click. No, we're gonna face like count anti-clicks issue. That's like insane. I guess. No, I don't know if it's that hard, but yeah, but we do have a set of numbers that are divisible by 2, right? I have no idea how many numbers there are. So we're gonna take this prime count so many prime numbers up to 72 we have. Nope. I'm gonna risk it. I don't know how. No, it should be cast to the right thing, but I don't want to think about this. Yeah, usually people write like this. That's I don't want to do this. Okay. Hmm. No, unfortunately, we will need +9. So we're going to do based on this, based on the condition. And the condition is, of course, going to be if C is divisible by ice prime. And we want to put back here. That's cool. That's cool because from every such set of multipliers, we can take at most one number. Which in fact means it's like we don't have that much of a choice. If we take one even number, then it's gone, right? It's just gone. Like half of the numbers in the middle get discarded. And because of that, like the answer quickly reduces. So what I'm thinking is just what happens if we just no, that's unfair. That's a lot. That's a lot. Well, like, but yeah, but then next numbers, like we can take only one number that's divisible by 3. I don't know. I also want multiplier of 3 numbers because then I can just from such numbers which are not divisible by any of these primes, man, I can just take them all or take any subset of them and do whatever I want, really. So they're going to be just oh, I don't want this, by the way, I noticed a mistake. How many such numbers we can have? I better do it like this. I'm gonna just multiply the result by this, right? Actually, I can just X conclusion now difference, but because I can take any subset of them and it does not impose any conditions. What I have is like I have prime numbers and I have my numbers from A to B. Some of them are connected. I want to select a pairing and I want to count how many pairings there are. And it sounds like it's simpler to select parent starting from PS, but I'm not sure that it is. Because it's not independently, that's the problem. How many numbers do I have actually? Visible by 2, I can have 36 numbers. Right? We should be careful here. 72 is 24 numbers. 5. It's 40. I already don't like when it's going. Oh, we should actually take 15 because we are rounding up. Here we have 11. Here we have 7. Yes. 6. I really don't like where this is going. Because then the maximum answer is the product of these guys. It's already a lot. Actually, I'm a bit mad. No, that's clearly not gonna fit. Come on, guys, that's not gonna fit. It's 25 million already. No. It's just not working because every one of these is going to be power of 2. I can have both of them divisible by 2. It would take a lot, though. I'm not sure if this is actually possible. The idea is just for every prime number, loop over and hope for the best. I don't have better ideas. Maybe this is going to kill you, but I don't have better ideas. Okay, so we're going to multiply it by this later. Right? And just like this. Just some backtracking. I really don't know what you guys want from me, so I'm going to do some backtracking. Can I please put back this thing? Thank you. Actually, yeah. Not interested in the prime itself, right? Same. If not used at M, we can still use at M equals true. Oh, we should have a separate function for this one. As parameters later. The idea is that we have like this kind of stuff. Oh, that's the wrong way to write it, right? We'll write backtracking here because we can, because C++, right? I'm sorry if you're hearing some strange noise. I don't really know what it comes from. Just I'm typing too intensely. Should have this outside. How about that? If we go to the end, then I just add one. Oh, so we can also do nothing. Kind of makes sense. I have no idea whether this is correct or not, but I have no better idea. So here we are, right on backtracking. Actually, the last time when I decided not to write backtracking, it was the wrong idea. It was cut process, I believe, in some Moscow informatics like that for school pupils, students, right? Yeah, so they kind of use that stuff. But I didn't, and I was wrong because it's all their problem. I don't really know if I want to. I don't want to create. Sort 3. Because it's recursive, I got to write the Is that a problem? See out what's right because it's a variable. That went surprisingly well. That's also went surprisingly well. Here I'm going to copy paste it. It works for quite some time. No way it's gonna make it. No, really, no. You can already see that it's struggling. So we need something better to calculate the answer, but I don't really know what. Let me just quickly check how bad is that. I have one wrong submission and we were kind of slow, so I don't know if we are any good today. It's still working. Is it? Right, it is. Man, I have no idea how you do it fast. But clearly a lot of people solved F already. Yeah, like a lot of people. Right. Yes, so you have to be smarter than backtracking. What else can you do? We already factored out the free stuff, so we just don't care about it. only have 50 numbers, right? Now I say 150. It's also going to be very slow. Okay, 120. Okay, 120 is instantaneous. 125 is also instantaneous. 130 took a while. 135 takes a lot of time. Okay. What if we just speed it up in a stupid manner? I don't really know if this is gonna work. It's very stupid. Like if we ran out of numbers and there was no need, so keep going. So how about we just apparently it still takes a while. Okay, how about 135 now? This kind of possible? Not really. We got some speed up from this because when we run out of available memory, there's only one way to continue, it's not to take anything. So in several cases, we can leave faster and reach the ends. But I guess it doesn't really make that much of a difference. I guess. Wait, is it actually correct? This is if we don't take it, and this is if we take it. Right, this. No, but then, okay, what if we say, you know what? Well, one number divisible by it. Why don't we just remove it? Right? Take it, don't take it to hotel. No, it's not free. It should be 2 times faster. for every element that you cleared in such a way. Oh, this is actually free. What is wrong? Boolean not findable searchable. If you tell me that int is not searchable in instance, okay. Pretty instance. Why did you do that? Why did you do that to me? Am I wrong or something? I don't understand. We should ideally just skip this I as well. But it should not make much difference. Like it only means, okay. The iteration over an empty container should define. So I doubt that our problem is here. Why did I recompile again? What is the problem, really? Okay. Oh, that was pretty fast, actually. That's nowhere near fast. That's gonna, yeah, now it like thinks for a while. How about these guys? Oh, that actually crashed it somehow. I have no idea how. All right, of course. What am I thinking? Like our optimization didn't really take place. I should have noticed. The answer was wrong. That's slow. No, that is too slow. Really, we're just gonna get TLE on the sample. And the answer is actually not correct. So I've done something wrong. Or is it because I counted? Wait, if I don't take numbers, then all previous numbers should be marked as used as well, right? Ooh, that's actually. I should unlock them at the very end. Only unlock the ones that I have to unlock. Not this one. Wait, why do I have to unlock them at the end actually? I don't have to, right? Wait. This is not necessary. Where is it? I'm confused. I want to make sure like that I take the first numbers that I can take, right? I'm going to check loop over all numbers that I can take. If they possibly could have taken. If I can't take a number because it's not used, then I'm going to mark it as used. Then push it back, it doesn't matter. I'm going to decrement the number of available numbers. I'm going to say like, okay, now give me the answer. Like this is number that I took. Otherwise, I'll keep like looping. And for next number, I'm going to use it as well. Meaning that this is actually the first number that I used. And at the very end, I'm going to count. Do I have to unlock? I don't know. Yeah, probably should do something like this. That sounds really strange. Takes it a bit to sync, but not that much. It's still too much, but how much is that? 2 million, and this like, oh, that's a lot. Do I really have to free you out? That's the question. Let's say I just say like that's it. And this is too little now. This is 10 times approximately too small. Yeah, I should have trained. Do I really? Yeah, I really should have trained by tracking what the heck. What the heck? I guess that's a problem because we can't distinguish if we taken the last one or we didn't take anything at all. Should I just use this then? Oh, wait, I should not do it here. Oh, I really messed this up. But this is interesting. Like this is legitimately challenging. This is wrong already. I'm trying to loop over all numbers that I can't possibly take. And it seems like what's gonna happen? The thing is that I want like not to take the same number further later, right? So like my idea is fine. Let me start with not taking anything, all right? And I'm gonna say like the first number I take is first number, so let me count this as well. I'm going to say, okay, now the second number, I'm going to take the second number. I'm also going to lock the first number, not to let you do anything stupid. This is too small because we undercount. Why do we undercount? 3 is the number of items that are already used. I'm not sure about this. Yeah, like if I don't have anything available, then like this is going to just be massive. It's like they speed up all this thing, right? And this also speed up all this thing. If you come on the side, the answer should not change. The answer was okay. Oh, the answer changed actually. This is strange. Why would the answer change? Because we subtract more. We should bring this part. Oh, I did it wrong. Oh, automatic testing would be nice. I'm going to take a lot of time. Right? Am I right? Yeah, come on, man. I can't wait it long. Yeah, no, it's really gonna take a lot of time. Wait, it's actually, is it doable? Just want to wait and check. Which time? 7. It's hard. Oh, this is not good. Like, why do we unlock actually? Unlock corresponds to not doing anything. We're just going to this branch. We should be able to go there. No, actually, synchronous, they should unlock. So after we come back out of this is not, yeah, we should unlock. And we should have these multipliers here. Multipliers are a speed up rate. I wonder how long it is going to take. Now we're well over. We count like 1,000 times more than we should have counted. Yeah, no, the idea is that when we go to the next step, the changes made here should disappear. Actually, didn't matter. Because so we're gonna lock everything up to the including the elements that we take first. And we're not going to take anything else. We're just going to ask you how many ways you have to finish this thing. Right. And like because when we are calling him, this function, when we call it, it should know who is locked and who is not locked. And when we took like first element and locked it and called the helper is going to lock some things. And we come back to our place. So like, okay, now we're going to lock the second one. And second one may be actually locked by the helper, right? That's not correct. Because like the helper locked it, it was not we who locked this element. This is confusing. I don't know if we're going to solve it. But I don't have better ideas. Like in theory, if we have pretty good concept, then it can work. Now, like legitimately here, the range is 50 and the answer is like 2 million. If you know that we go like to every correct branch, we don't go to many wrong branches, then we just fine. It actually sounds strange to me that we always return 1 once we go here. And everything kind of looks like it's right. I don't know, have it finished? Yeah, it has finished. It was... I don't understand where we are double counting, to be honest with you. This is kind of confusing. When we go to the cursor branch, we clearly say like what we used and what we haven't used. Did not know what it can use. Actually, it should only make cost what it can use. Therefore, I don't really understand what is going on. Now let's look through one more time. Have 10 minutes left. We have prime numbers. We know how many of them are. We would like to know which numbers are divisible by which primes. To create multipliers, we would also like to know which numbers are used. I'm gonna create this array. All power all numbers. If it's divisible by anything, I'm gonna push that to the corresponding multipliers. If it's not divisible by anything, then we're gonna use it. And used means that, like here, it means that we can either take it or don't take it. And then we look over all multipliers and we think, well, actually, if I have only one number, then I'm not really a constraint. We can take it, we can leave it. Oh, is it wrong? Yes, it is wrong. This part is actually wrong. Because what we really should think is if a number is... Yeah, no, this part is just wrong. Then our solution... No, stop it. Yeah, but like the fact that this prime number divides only itself does not mean that... Well, actually, we can clear it, but we should not make it used. Thing is, we're not going to arrive to any contradiction with that number. Or are we? Didn't I factor out 3? Not used. All right, I guess we just have to remove it completely. It already takes a lot. Yeah. No? Oh, that's just too much, right? It's already too much. It's like 26 million for 40 numbers, and here we have 50 numbers, and we just want 2 million. So we are still massively overcounting. Despite the fact I removed lots of stuff. Yeah. Yeah, I really don't know how to write this kind of backtracking thing. I hope this is actually what they wanted, because I kind of don't know anything about like how to count anti-clicks in the graph, even if it's bipartite. Just have no idea. Maybe there's just a specialized graph algorithm that I don't know, but it would be really unfortunate to spend that much time on trying to measure concursion work when it's really a graph problem. I really don't know what to say about this problem. Like, I really need to debug it for a long time, and then maybe it's going to work. I doubt it's really interesting to watch. I doubt we're going to arrive to any like good solution. That's definitely not a good solution, even if it's correct. So I guess it's gonna be it for today. Sorry for disappointing you guys if you expected more from me, but sometimes just how it goes. You can't solve all problems all the time. I mean, 5 problems is still not bad, I guess. Obviously, I wanted more, but you wanted more. Sometimes you gotta start with what you got. What you got. So, thanks everyone for watching. I guess that's it for today, and goodbye, and see you tomorrow, hopefully with another AtCoder contest or regular contest. So yeah, bye bye, jump on.